In this video, I will explain you a very important concept which is permittivity. In the last video, I have explained you what is force in between two charges Q1 and Q2 kept in a media. We got the value as F is equal to C Q1 Q2 divided by R square. And we have learned that value of C depends on in which medium it is placed. So what will happen for the force in between two charges when it is kept in different media? So let's say Q1 is exerting a force on Q2. So this is positive charge, this is negative charge. Now this will be attracted by electric field lines. The concept I will explain in the coming video. Anyway, you can say, you can understand that there will be a force exerted on Q2 by Q1. So Q1 will attract Q2 inward direction. So this will be done with the help of field lines. So there will be field lines. These field lines are basically pulling Q2 towards Q1. So here also I can, so from positive to negative will be the field line. So the reason for this and explanation for field lines I will give you in the coming videos. Anyway, Q2 will be attracted by Q1 in this direction. Now when it is kept in a medium, in air, this will be in this way. But when we are inserting a dielectric or a medium in between Q1 and Q2, what will happen? See, it was supposed to have, say for example, 4, 5, 6, 7, 8, 9, 10. Say for example, previously there existed 10 field lines which are attracting Q2 towards Q1. So Q1 exert a force on Q2, so it is attracted towards Q1 with the help of 10 field lines. Say for example, when we are inserting a media in between Q1 and Q2, out of 10, some of the field lines will be absorbed by the media. So 1, 2, 3, 4. Let's say 4 are absorbed. What is remaining? 6 field lines are remaining. What will happen to the force exerted by Q1 on Q2? The force will obviously reduce because it is field line exerting force here. Okay. So now read the definition for permittivity. Is an electrical characteristic of media. Okay, so medium is absorbing the field line, right? So instead of explaining it as absorbing the field line, we will explain in this way. It's a electrical characteristics of a medium due to which it absorbs effect of a charge. What effect? Due to which force is applied on other charge. Now Q1 is applying a force on Q2, that is effect, right? So this force will be decreased. The reason is field lines are absorbed, and this property is called as, this property of a material is called as permittivity. So higher the permittivity, more field lines will be absorbed by the media, so that the force will get reduced. So we know that C is inversely related to epsilon 0, because as per this equation, when value of C increases, force have to increase. But as per the definition, epsilon 0, which is denoted by, as per the definition for permittivity, which is denoted by epsilon, I could say that when value of epsilon increases, permittivity increases, more number of field lines are absorbed, and force get reduced. So C is inversely proportional to epsilon 0. Higher this, lower will be the value of C. Okay, with experiment we have found out the value of C, which is 1 by 4 pi epsilon 0. Now this equation can be rewritten as 1 by 4 pi epsilon 0 Q1 Q2 by R square. Now epsilon 0 can only be written when there is air or when it is kept in free space. Basically air and free space can be taken as the same. Actually it will be different when we are keeping in air, because air means air particles are there, right? So that is basically a media, but we are considering air and free space as almost the same. Actually it is different. So here when it is kept in free space, it is epsilon 0. And the value is 8.85 into 10 power minus 12. How to get the unit, I have not mentioned unit here, we will get it together. So from here, epsilon is equal to Q1 Q2 divided by force into 4 pi into r square. So I will keep force here, epsilon I will bring here. So epsilon 0 is equal to 4 pi r square in the denominator, Q1 Q2. So what will be the unit of Q1 Q2? C square. Unit of force is Newton. Unit of r square is meter square. So this will become C square Newton inverse meter power minus 2. So C square Newton inverse m power minus 2. This is epsilon 0. This is epsilon 0 of free space. Now, when a medium is kept, then we have to mention it as epsilon of that media, permittivity of a media. So epsilon 0 will be in free space, but when we are keeping in a media, then medium, so I will mention it here. So the force will become 1 by 4 pi epsilon, permittivity of that medium into Q1 Q2 divided by r square. The same thing, epsilon 0 will be changed by epsilon. Here it is free space, here it is medium. Now this will be the value of force in a medium. Now force in air or free space is equal to 1 by 4 pi epsilon 0 it will be. Okay, Q1 Q2 divided by r square. Divide both the values so that 4 pi will be cancelled, Q1 Q2 will be cancelled, r square will be cancelled. What is the case here? Two charges, one in vacuum, then we are keeping it in a medium. That same distance and same charges. Only the change here is medium has got changed. So force in medium divided by force in air is equal to, or free space is equal to, this epsilon. So this divided by this. So 1 by epsilon medium divided by 1 by epsilon 0. So this will become epsilon 0 divided by epsilon m. Okay, so this is 1 by epsilon m, this is 1 by epsilon 0, epsilon 0 will come to numerator and epsilon m will be there. So force in medium divided by force in air or vacuum is equal to, vacuum, free space here it is, epsilon 0 divided by epsilon m. Just find the inverse of this equation, that is f0 divided by fm is equal to epsilon m divided by epsilon 0. Why I have kept in this way? So that I will have epsilon 0 in the denominator. Now this is defined as epsilon r. Relative permittivity. See, what is the relative density of any substance? Density of that matter divided by density of water. So we have taken a standard element in the denominator. This is relative density, right? Density of material divided by density of water. Similarly, we are defining a standard here, which is permittivity of free space as epsilon 0. So which is f0 divided by fm. Okay, so force, just find the value of force in free space, then keep in a medium with the same charge and with the same distance in between them, find the ratio. Force in air divided by force in medium. That will be the value of epsilon r. This is relative permittivity. So relative permittivity has been defined as permittivity of medium divided by permittivity of air, or ratio in between permittivity of medium and permittivity of air. Now what will be the unit of this? It's a ratio, right? Force divided by force. It's a unitless, dimensionless quantity. Okay, this is very important. Now I will tell you an application of relative permittivity. See, we have learned that the force, value of force will decrease when we are taking it from free space, Q1, Q2 from free space to a medium. Force will decrease, right? Now, in electrolysis, what we are going to do? Salt we are going to dissolve in water and we are going to do process of electrolysis for separating the ions, right? What is the reason? In air, Na plus and Cl minus are very close to each other. Now the force of attraction is very high. But the same Na plus and Cl minus, when it is dissolved in water, the force in between Na plus and Cl minus will be less because of the relative permittivity of this medium. So what will happen? You can easily separate the ions. So here force is less, here force is more. This is just an application. Okay, thank you.